All right, I'm going to go through the rest of the problems. The problems are from an old exam. All right, so if you can do these problems, you should do quite well on the test. They will be similar, not identical. All right. So number 5. X is a new element. All right, so this is using your naming system. So XO2 minus 2 is called Xite. All right, so that is given. So you have to know the last 3 letters, very important. Ite. All right, so when you have Xite, you have to know your chart. Oh, did we do those already? I guess we did those already. All right, again, Xite. Remember, when you add an oxygen, ite becomes 8. You add another oxygen, add one to the 8, it comes a per 8. If you take one away from the Xite, it is hypoite, is how it is the ending. So make sure you know that naming system. All right, so number 6 is the one we're on, and that is the easiest question on the test. Do not miss the easiest question on the test, and that is simply protons, neutrons, electrons, and you're given a periodic table. All right, so sodium 23. All right, you look at the periodic table. Sodium is element with an atomic number of 11, and that is the number that goes down bottom left. All right, if this is 11, this is sodium. If this is a different number, then this is a different element. 11 is sodium, and 11 is the protons. All right, so you have 11 protons. If you've got 11 protons, you've got sodium. If you've got sodium, you've got 11 protons. That never changes. Electrons can change, neutrons can change, protons cannot change. If it's sodium, it's 11 protons. The atomic number of sodium never changes. That is the number of protons. All right, and so you have to know that the 23, this is your mass number, this is your protons plus neutrons, and this is, of course, your protons, so a simple subtraction gives you 12 neutrons. All right, now there's no charge given here, so it's a 0. If it's neutral, there is nothing that will be written here. And what that means is your protons, when it is 0, that means that your protons equal electrons. All right, so when your charge is 0, that means your protons equal electrons, and so you have 11 electrons. All right, so the next one is the same thing except a plus charge, so Na plus. All right, 2311, that never changes the protons. Sodium is 11 protons. You'll never see it any different. 11 protons. This is your mass number, 12 neutrons. All right, but now we have an overall plus charge. So that means we have one more proton than we have electron. Well, we know how many protons we have. We have 11. And that is one more than the number of electrons. And so you have 10 electrons. So you have 11 pluses and 10 minuses. Overall, you have 1 plus charge. All right, so when we go to chlorine, 35. All right, you just find chlorine on the periodic table. It is number 17. All right, so you have your nuclide symbol. This is called a nuclide symbol. Make sure you know the terminology. All right, so again, this number is always the number of protons. You got 17 protons. You add these up to get, you have the protons plus the neutrons here. When you add the protons plus the neutrons, you get 35. That means 18 neutrons. There's no charge here. There is a 0, nothing here. All right, nothing is listed there, so it is neutral, which means your protons equal your electrons. All right, so these should be by far the easiest questions on the test. Chlorine, that is 35. That has a minus charge. Again, if you're chlorine, you have 17 protons. That never changes. This is your protons and neutrons. That's 18 neutrons. Now, overall is minus, which means we have one more negative than we have positive. One more electron than we have proton. And so we have 18 electrons. All right, so you can change the number of electrons. Protons, if it's 17 protons, it's chlorine. If it's chlorine, it's 17 protons. That never changes. If we would have put chlorine 37, that was not one that was listed, chlorine 37. All right, and so you have, again, 17 protons because it's chlorine. That never changes. You have 17 protons if it's chlorine. All right, but now we have 20 neutrons, and it's neutral, and so it has 17 electrons. All right, and so when we look at our chlorine 35 and our chlorine 37, you have to know what those are called. So they have the same number of protons, same number of electrons, but a different number of neutrons. All right, so these are isotopes. All right, so these are the two isotopes of chlorine. All right, same number of protons, same number of electrons, but a different number of neutrons, which means a different mass number. All right, and when you look at the periodic table, you see that chlorine is 35.45 is the molar mass. So it is more than 35, but it is less than 37. And it's closer to 35 than 37. And so it's actually about 75% chlorine 35, 25% chlorine 37, which is our next question, which is number 7. All right, so we're not talking about chlorine anymore because our mass numbers here are 63 and 65, not 35 and 37. But it could have been chlorine instead of this element here. All right, so your element has two naturally occurring isotopes in number 7. All right, and so you have your isotopic mass. So you're going to be given an isotopic mass, and then you're going to either be given a fraction or a percent. This one is fraction. All right, so the first one is 62.930 AMU with a fractional abundance of 0.6909. So 6909. And if we wanted that as a percent, it would be 69.09%. All right, the other isotope doesn't give a fractional abundance. However, in the problem, it says there are two of them. All right, and so 64.928 is the mass. This is not given, but we know that there are only two, and they have to add up to 100%. All right, so if this is 69.09, then this is going to be 30.91%. All right, but we want it as a fraction. All right, and so when you add up the fractions, if you add up the percents, it's 100%. If you add up the fractions, it is 1,000,001.000. So the fractions add up to 1, multiply it by 100. The percentages add to 100%. All right, so we have to multiply our isotopic mass by our fractional abundance. All right, and so when we do that, we have our 62.930 times 0.6909. All right, and so you had 5 sig figs times 4 sig figs, so you give your answer to 4 sig figs, so that is 4348 AMU. All right, so then we do the next one, which is 64.928 times the 0.3091. And that is 20.07. Again, 5 sig figs times 4 sig figs, you get 4 sig figs. And now to get the molar mass, you simply add them up. And so you have your 0.55 and 63. All right, so 63.55. Then you go to the periodic table. All right, so then we. Huh. All right, so we had 63.55, and then you have your periodic table, you see, and this is the periodic table that will be given on your test. So it is the one in your book. You have your atomic number, you've got your symbol, and you've got your atomic mass. And so 63.55, you see that that is copper. And so now you go back here and you say that that is copper. So all right, so what else does it say? Calculate the molar mass. All right, so this is the molar mass, AMU. Make sure you put AMU or grams per mole for your molar mass. The nuclide symbol for each isotope. All right, so the nuclide symbol for each isotope. All right, so the nuclide symbol, you have to know what that means. That means you're doing the copper and you have to have a number here. And so you go to the periodic table again. All right, so you find your copper, make sure you know the atomic number. So copper is 29. All right, again, you're given a periodic table. You don't have to memorize that copper is 29. All right, so now you know that copper is 29, so that number goes here. Now the mass number, these are isotopes, isotopic mass isotopes. They are two different isotopes. And this number, these numbers are always integers, and so you round it to the nearest integer. So 62.9 is 63. The other isotope is copper, not 64.9, but 65. These are integers. And still 29 because it's copper. All right, so those are the two nuclide symbols for the two different isotopes. All right, and then the easy part, give the number of protons, neutrons, and electrons. We already did an isotope, and we will see that this isotope works out the same. All right, so protons, 29. Protons, 29. If you're copper, you are 29 protons. All right, so then you do the subtraction. You get your neutrons. That is equal to 34. You add those up, you get 63. Over here, you need 636 because when you add those up, you have to get 65. All right, they're both neutral, so your protons and electrons are the same. Electrons, 29, it's neutral. Electrons, 29, it's neutral. Protons, neutrons, the same number. All right, so again, the definition of your isotopes, they have the same number of protons, electrons, but a different number of neutrons. All right, so that gives them a different mass number. All right, then many points on the test are going to be, well, naming, except number 8 is not, well, it is naming. It's not necessarily naming, but if you cannot draw the formula, you cannot get the right answer. So if you don't know how to name things, you're not going to be able to do a lot of stuff on the test, and that gives you lots of zeros, which gives you a bad grade. Make sure you know your nomenclature. Give the formula for ammonium sulfate hexahydrate. Ammonium sulfate hexahydrate. So ammonium sulfate, so you have to know ammonium, NH4 plus, right off of your memorized chart. Sulfate, also right off your memorized chart, SO4 minus 2. You have to know how to do hydrate. That means that you're going to have some number of water. You have to know hexa is 6. And so we have 6 waters. All right, so now you have to make a neutral compound out of that. All right, so you see you need 2 of the NH4 pluses because it has to be neutral. You can't just put these together. That would be an overall minus 1. So you have to have NH4. You have to have 2 of them. When you want 2 NH4s, you have to use parentheses and a subscript 2. And then SO4. Now you have a neutral compound, but that's just ammonium sulfate. You need the hexahydrate. When you do the hydrate, you put a little dot, coordinated 2. It's like a multiplication dot. 6, H2O. That is your hexahydrate. All right, but that wasn't even the question. Oh, yeah, it was. Give the formula. Okay, then the question is how many hydrogen atoms are there in this compound? All right. Well, when you have 2NH4, this is 8 hydrogens here. And when you have 6 H2Os, you got 12 hydrogens here. So you have a total of 20 hydrogens. Again, you could not answer that question if you have the wrong formula, you're going to get the wrong answer for that one too. All right, so you have to have the right formula, and you have to be able to count how many hydrogens that you have in that formula. All right, so 9 is that is the only part of the problem, and that is to give the name. All right, and so this is whether you have memorized your nomenclature or not. All right, so CuCl. When you look at the periodic table, all right, you find chlorine over here, number 17, in the -1 column. All right, so remember your first column here with hydrogen, lithium, sodium, that's +1. Your beryllium, magnesium, calcium, that's +2. Then you have your transition elements. These have multiple oxidations. Not all of them. Some of them you have memorized that only have a single oxidation. All right, now your boron column, that is a +3, but when you come down, you're going to have different oxidations as well. All right, but your boron, aluminum, gallium, those are in the +3. Carbon doesn't have a number. We have tin memorized. It's 2 and 4. Lead is the same. It's also 2 and 4, but I didn't require you to memorize the oxidation of lead, but they're the same as tin. All right, and then you have your -3 column for your nitrogen and your phosphorus. Note when you get down here to metals, they're not going to be -3. So the minuses are for the non-metals and metalloid here. Then you have your -2 column, right? And then you have your -1 column, and then you have your noble gases, which do not form binary compounds. All right, and so when you have your chlorine, you know that's -1. And so copper, which comes in 2 oxidations of 1 and 2, if you have 1 chlorine, then you have to have a +1 to make the neutral compound. All right, so we know that this is chlorine. To make this neutral, we know that chlorine's in the -1 column, and so the copper has to be the +1 copper. Again, you have to know copper comes with 2 oxidations. It's +1 or +2. And so this is a copper 1 chloride. And again, the last 3 letters, very important. So again, binary compounds, 2 elements, always end in IDE. CAS, so calcium's in the +2 column, sulfur's in the -2 column. And so calcium is always +2, sulfur is -2 in binary compounds. All right, and so you have a neutral CAS, which is calcium. And if you write calcium 2, that's the wrong answer. You only put the oxidation when there is more than 1. When it's in the +2 column, it's always +2. And that is calcium sulfide. Again, IDE, binary compounds, all end in IDE. All right, now we have chlorine and oxygen. Now we have 2 nonmetals together. All right, when you have a metal with a nonmetal, like copper and the copper 1 chloride and the calcium sulfide, you have ionic compounds. All right, so these are ionic, which is a metal with a nonmetal. All right, and you are not allowed to use the Greek prefixes for ionic compounds. When you have Cl2O7, you have 2 nonmetals. So this is a molecular compound. All right, and so you must use the Greek prefixes. So this is then the first one, just like here is copper, here is calcium. The first element is the element name. All right, so dichlorine. And I'm looking very hard at the chlorine. If you call it dichloride, it is wrong. I'm not really that particular in spelling except the ending. All right, so dichloride is wrong. It's not misspelled, it is wrong. The dichlorine, and then you have 7 hepta. Now oxide has to end in IDE because it is a binary compound. So dichlorine heptaoxide. If it's multiple choice, one of the choices is going to be dichloride heptaoxide. That is the wrong name. The first element is the entire element name. All right, Fe2O3. Again, now we have metal with nonmetal. We're back to ionic, Fe2O3. And we see iron on our periodic table, and it is in the transition elements, which means it's going to have, well, doesn't mean it's going to have, we have it memorized that it has two different oxidations. So you have to be very clear which oxidation that we are looking at. All right, so you have to know that oxygen's in the -2 column. All right, so you've got 3 oxygen -2s. So that means that to have a neutral compound, and this tells you have 2 irons, each one of them has to be +3. That gives you a +6 and a -6, and that gets you a neutral compound. And so this is not iron oxide because there are 2 different iron oxides. This is iron 3 oxide. All right, you could also call this ferric oxide, the higher of the 2 oxidations. You have to know iron comes 2 and 3. And back with the chlorine, or the copper 1 chloride, that is the lower of the 2 coppers. And so that would be also called cuprous chloride. So you don't, when you're naming it, you don't have to use those terms, but you have to know what they mean because of number 10. Which is I give you the name and you give me the formula. If you don't know that cuprous is copper +1 and I put that there, you're going to get that wrong. All right, so make sure you know that ferric is iron 3 and cuprous is copper 1 because I could just reverse those and give you the name cuprous chloride and you have to give me the formula, CuCl. All right, nitrogen trifluoride. Again, we use the tri, which means it is a molecular compound. And so you have a nitrogen, and then you have 3 fluorides. Ends in IDE. It is a binary compound. 2 nonmetals, molecular. All right, and B. All right, so this is beryllium. All right, so that's Be, beryllium. You have to know that's you have to know that element. It's right in column 2. It is a beryllium, which is +2. And then bicarbonate. You have to have memorized your bicarbonate. That is your HCO3 minus. All right, and so now you have to make a neutral compound out of a Be that is +2 and a bicarbonate, which is HCO3 minus. Right now that's +2 and that's -1. We have to have 2 of the bicarbonates. And so you have Be and then HCO3. Then to get 2 of them, you have to use the parentheses and a 2. Now you have a neutral compound. Calcium hydroxide. Calcium is Ca. It's in the +2 column. Hydroxide is your flashcard, memorized, OH minus. All right, again, it's not CaOH because that would not be neutral. All right, you have a +2, you have a -1. You have to have 2 -1s. And to get 2 OHs, again, you have to use parentheses and a sub 2, calcium hydroxide. Nickel, you have nickel memorized as Ni+2. It is a transition element, but it only comes in a stable form of +2. And so you don't need nickel 2 phosphate. If you put nickel 2 phosphate, if you put the oxidation numbers of any of the transition elements, I will not count those wrong. Nickel does not need it. It only comes +2. Phosphate, PO4 -3. All right, and so now we have to have a lowest common factor or lowest common multiple of 2 and 3, which is 6. So we need 3 nickel +2s to give us a +6. We need 2 phosphates to give us a -6, and that will give us our neutral compound. And so to write that formula is Ni sub 3, and then the PO4 parentheses, and then a sub 2 to get that to be a neutral nickel phosphate compound. All right, then number 11. All right, we have CH3OH, methanol plus oxygen. We're doing a combustion. And why there's a 2 in front of the CO2, not sure. All right, CO2 and H2O. That 2 should not be there, at least not in the problem. All right, not sure. Okay, so carbon can be balanced first. It's only in one spot here, it's only in one spot there. And so we have one carbon, we have one carbon. Hydrogen, we have it in one spot, one substance on the left, one substance on the right. All right, so 4 hydrogens here. And so there is then a 2 here. And then we do the oxygens last. Over here, we have 2 oxygens and we have 2 more. So we have 4 oxygens. Right here we have 1. And so to get 3 out of a sub 2, that means we need 3 halves. All right, or 1 1/2. So if we take 3 halves of 2, then that gives us 3. If you multiply 3 halves times 2, you get 3. All right, and that's 4 oxygens, except we do not use fractions when we balance our equations. We have to have whole numbers. And so we have to multiply the whole thing through by 2. All right, and so when we do that, that's probably why there was a 2 in front of this, but whatever. All right, so that's times 2 is 2. Get rid of that. Now that's 3. Put a 2 in front here. Get rid of that 2, multiply it, and it is 4. And so now we have 8 oxygens, 2 here, 6 there, and we have 4 there and 4 there, and we have 8 oxygens. 2 carbons, 2 carbons, 8 hydrogens, 8 hydrogens. Make sure when you balance your reaction, you do not give any fractions or decimals. Multiply it through. Make sure you have whole numbers for balancing your reaction. All right, KClO3. Goes to KCl and O2. All right, K, one spot, 1K, 1K. Cl, one substance, Cl, Cl. Oxygen, one substance. All right, but now they're not balanced. So again, you could then put 3 halves here. All right, so now we have 3 oxygens on the left, and now we have 3 oxygens on the right, except, again, you cannot have a fraction. All right, and so again, your denominator is 2, multiply it through by 2, and so you have then your balanced chemical reaction, 2 of those, and 3 of those, and you would check 2 Ks, 2 potassiums, yes, 2 chlorines, 6 oxygens, you have a balanced chemical reaction. All right, so if you are good at balancing reactions but not good at names, you are not going to do well on the next one. Part C, calcium phosphate. So you have to know that calcium is in the +2 column. Phosphate is memorized on your flashcard, PO4 minus 3, plus carbon. All right, so carbon is simply the element carbon. Yields calcium phosphide. Again, you have to look at the last 3 letters. That tells you everything. IDE. All right, and so now, once I see it's IDE, phosphate was memorized. If it was ite, I would take off an O. All right, when it's at IDE, and it will be typed up, so it will be 0. I can't read your writing. It's all typed. IDE, that means you have a calcium +2. You find on the periodic table here phosphorus, all right, which is right underneath your nitrogen, and that is in the -3 column. That's -3, that's -2, that's -1. It's in the -3 column. All right, and so that is a P -3. All right, so then that is calcium phosphide. phosphide we're going to make. And then finally you get carbon monoxide, which everyone knows is CO. All right, so to form your neutral compounds and then balance your reaction. Again, the least common multiple of 2 and 3 is 6. So again, you need 3 of these to give you a plus 6. You need 2 of these to give you a minus 6, and that gives you a neutral compound. The way you write that neutral compound, to get 3 calciums, it is Ca sub 3. Then PO4 in parentheses sub 2. Your carbon is just your carbon. All right, over here, you have your calcium that's plus 2 and on your phosphide, which is minus 3. Again, least common multiple is 6. You're going to need 3 of those and 2 of those again. So again, you have Ca3P2. You got your plus 6, you got your minus 6. And then CO is simply carbon monoxide, CO. All right, and so now you balance this reaction. All right, calcium in one substance, 3 there, check. Phosphorus in one substance, 2 there, check. Oxygen, one substance. And you have 8 oxygens here. In order to get 8 oxygens here, you have to put an 8 in front of your CO. And then carbon in one substance here, one substance there. We have 8 of them over here. We need 8 of them here. All right, so it's a very easy problem to balance, but it is not that easy to get the formulas. If you get the formula wrong, it's going to be impossible to balance. So make sure you know your nomenclature so you can get the formulas and be able to balance the reaction. All right. So that is the end of those problems.